Alright, now that we went through that daunting task of putting together the TcpSocket listener and the TcpSocket, let's go ahead and review what we did in the TcpSocket. Now, I'm not going through and explaining every single bit of line of code since I already did that while we were coding the TcpSocket. I'm just going to summarize everything. We've got our buffer size for the maximum amount of data we can receive at once. We've got our size buffer length, which is the header right before the payload, so we know how much data is actually coming. We've got our properties. This is so we can know if the socket is connected or not, if it has been disposed or not. We have our events for connection state, data is data that's been received, and also if we were disconnected. And we've got our variables here, this which holds the receive buffer for our receive processes. And then we've got our variable that will hold the full payload size. This will hold the full payload if we have to receive multiple parts. Send sync is for the send rapid method, just so we can make sure that the header and the payload for the packet is sent at once. And if we're doing this in a multi-threaded environment, the header for one isn't sent, then the header for another is sent, and then the payload for the first one, and the payload for the second one, just to make sure stuff like that doesn't happen. And of course, the main thing we need, the variable for the socket that we're wrapping. We've got the constructor, we've got a parameterless instructor that's for the client side. This will automatically create a socket that we can use to connect, and then it'll also initialize the buffer, the receive buffer I mean, and if the constructor that takes a socket will just set the internal socket variable to the socket, initialize the buffer, and also begin reading, because we can assume that the connection was already made beforehand. And the deconstructor just calls dispose. Now in our methods we have initialize buffer, which just instantiates the buffer, the byte array in memory based on the buffer size. This will check and see if this class is disposed. If it is disposed, then it'll throw an object dispose exception. It's just a little helper method. And with connection, we guys know what all this mess does. It's so we can connect to a server, begin read. This starts the read cycle, which receives the buffer length first, or attempts to receive the buffer length first, I should say, and then receives the buffer length, creates our payload stream, gets our payload size, etc., etc. You guys have seen all this already. Our helper methods we can call our event. Our send methods, of course, which combines the size and the actual payload together and then sends it off at once. This is just in case there's still a memory leak in the .NET framework if you have to send data rapidly. And of course the send callback, just to end out the asynchronous send method. We have our disconnect. In case we want to disconnect this socket and then reconnect to another without having to instantiate another class. And then we have our cleanup method, which just releases anything that's not being used anymore for memory. So now that we have our class reviewed, let's do something actually testable. Before we were just doing some, oh, actually we don't have to have this here anymore. We were just testing connection, we were stress testing, but now let's just put together a simple client-server chat example so we can make sure everything flows the way we want it to flow. And we don't run into that many issues. Okay, so first what we'll do is let's get rid of this right here. And let's also get rid of this. And let's code the server first. I'm going to spitball this. So we're going to put this. I'm going to put this together on the fly. So what we can do is, if the server is started, let's set the title to server so we know which one is which. And if a connection is accepted, let's go ahead and stop the listener. Actually, let me double check and make sure that this doesn't shut down. Okay. We're going to stop the listener because we don't need to accept any more clients. Or this is only going to be one by one. We're not going to do multiple connections, at least not right now. That requires a little bit more of a crazy setup. So what we're going to do is we're going to stop the listener, and then let's spin off another method called begin chat server, and we'll pass the accepted socket into this method. Just go ahead and have it generate for us. Actually, let's just name this begin chat actually. Okay, and now we'll set up our data received event. Call this DS and DE. And we'll also have a boolean to indicate which side is actually receiving, so we know what we need to write to the console. String name equals is server or a client. And since we're inside of a server method right here, we'll just pass true. And now when the data is received, we're only going to be sending a string, since that's going to be the only thing we're going to be sending back and forth. We're not going to do anything really intricate right now. We just need to make sure everything works the way it should work. So what we're going to do here is call console.writeLine parameter 1 and parameter 2, which will be the message. We're going to pass name and then DE encoding .ASCII.getString DE.payload. And that's it for sending messages back and forth, actually. Well, for receiving messages. Now we need to add client.disconnected yes and DE console.writeLine client actually has disconnected name. And what we're going to do here is have it actually loop and repeat. So if we are using the server, it can accept another connection. So if it is the server, we're going to call the server method again so it can reloop, set up the listener, and wait for a connection. It should be it for this side. Okay, now that we have the receiving part, which is begin chat, that'll be used for both the client and the server methods. Now we need to get the actual input. So we'll put this in a true loop. And we'll have string message equals console.readLine if message dot to lower is not equal to disconnect. then actually var no, TcpSocket client equals null, and if once the connection is accepted, we're going to set our client variable to the accepted socket. Now if the message is not equal to disconnect, then we're going to get the message payload using the encoding ASCII class with get bytes instead of get string like we did down here. And we're going to pass in the message. And then we'll call client.sendAsync message payload. Okay, we should add another method in here actually in case there is a disconnection midway so we can exit out of this loop, which I should add later on. We'll do that later on. Now let's head over to the client. And this was already basically set up for us, but we're going to add another else statement to e.connected because it's just going to keep looping and keep trying to connect. So let's do that first. In the else statement, console.writeLine, connection could not be made. Retrying in 2 seconds. And then we just call the client method again. If it is connected, however, we're going to call begin chat. We're going to pass false this time instead of true, since this is not in the server, and we'll pass the socket. And another thing, I just realized I flipped this. In begin chat, swap these two out. So it should be client and then server, because this is what will actually be coming in. This is what we'll be writing to the console. I had it flip-flop, so I was thinking of something else. But as far as this loop is concerned, we'll check and see if the client is still connected before we send a message out. We'll still write if the console, whichever side was disconnected, and if it was disconnected, if you try to send a message to the server, for example, then we'll have it loop around. There's really no point in doing too much in just a proof of concept, because this setup is kind of hard to actually get something like that flowing correctly. So if client dot connected, then we'll go ahead and go through this. If it's not, then we'll break out of the loop. And then we'll call the server method again. So go ahead and get rid of this. Okay, and inside of the server client, if the client is, if the input is disconnect, then we'll call client.disconnect. And then also break out of the loop. And that looks like that should do it for our test. Let's see. Everything runs correctly. Same thing like we did last time. I'm going to start the server. Then we're going to start the client. something went wrong. Let's see what happens here. So we're started up. Let's actually shut this down afterwards. Client. Okay, let's try this again. Ah, okay, that's what happened. So instead of doing that to keep it open, that's why I was screwing up. We're just going to use, and from the system the diagnostics class, don't worry about this too much. Get current process. Wait for exit. This just waits for the process to actually be shut down instead of waiting for input for it to shut down. And let's go into the client method. We do console.title equals client. That was the thing that was missing. Let's add a few more indicators as well. Like console.writeLine, client connected, so we can see the flow as it's going. Console.writeLine, waiting for client. Console.writeLine, client. Where's the client accepted? Then we get chat. Console.writeLine, chat ready. If is server. No, scratch that. Right, we're doing this up here. So let's go back up here and start it up. Waiting for client. Client accepted, client connected, chat ready. Waiting for client. Why is client not accepting any input? Because I didn't add the chat portion into the client side. Herpaderp. And instead of client, we'll just name this socket. And if you missed that, I just went and copied the while true statement into here, changed client into socket. Okay, so the data is going through from the client to the server, but not the server to the client for some reason, and we're getting a no reference exception in place of that. So let's go and see what's happening with that exactly. Instead of e.acceptedClient, since we're setting this into a variable, just go ahead and set it to client. So if we look at this, if we send a message from the server side, we get the message waiting for client. Let's use some breakpoints and see why that's happening. And the Visual Studio does stop freaking out. Okay, let's head over into our server method. That means the loop is being broken somewhere. Let's try sending another message. No reference, okay. Restart. Okay, here. So the loop is being broken at the client connected else statement, which is why it was calling the server method again, which is why we're seeing waiting for client. So connected is not being set. That's the problem with this side. Let's head back into TcpSocket. Go into the constructor right here and set this.connected equals true. That was the problem. Let's get rid of our breakpoints. Start up another instance. Okay, let's send test. Okay, so we're still having another issue. The client's going through to the server, but the server's not going through to the client. Let's look at our server method again and see what we're missing. Oops. Okay, I'll send a message to the server. Okay. And I'm using F10 to step through the lines of code. Everything here seems to be lining up as it should. And it's sending through one side, so it must be sending through the other, which it is. But for some reason it's not being received. This method's not being called. Send is being called, but receive is not. Let's put a breakpoint and resize callback, both on if read is less than equals 0. Okay, it appears it's not actually reading anything. So let's shut both of these instances down. And we're going to follow the server side of the client. Okay, here. So we're sending connected to true. We're initializing our receive buffer. Now let's step through and watch this. Okay, socket was accepted. Everything worked fine, and an exception was thrown of no reference in the accept callback. Line 64. Okay, listener and accept. Okay. Okay, no exception was thrown. That's working the way it should. Okay. Then it starts reading. And the exception being thrown is probably from the ending. Yes. Okay, that's where the exception was coming from. Okay. So that's working the way it should. And begin read is being called on that socket. Like, everything seems to be fine in this end. Let's go back into the TcpSocket. Size buffer, begin read is called. Let's go look at the connect methods. Let's go look and see what's happening on connect. Okay, check disposed. It's calling the event. Okay, this next line of code is not hit. Let's restart the test. Now I'm going to use F11 to step into it. Okay, now we're in our async connection result callback. And this is where it's deadlocking. So everything was working just fine. It was this code that we have that's preventing it from receiving. That's an easy fix, however. So let's shut this down. Let's go back into TcpSocket. And it's a good thing that this was caught beforehand. And this is also a good tip too. Before you call any event, make sure you do everything that's critical beforehand, or the user of the library might deadlock it by using up the thread that's being used for the in-connect method, the in-connect callback, I should say, and potentially screw up the library itself. So if you're writing a library that's going to be public or even for yourself, make sure you do everything critical beforehand. Now let's see if this works properly. Okay, now our callbacks we set before are being hit. So is the event. And server says hello client. And now we also have hello server from the client. Now let's shut down the client and see if it disconnects and loops properly. Client has disconnected. Connection cannot be made. Okay, so that means it's not looping right. Oh, because we didn't check for the actual disconnection itself. Let's disconnect the client. All right, and waiting for client, there we go. And voila. Now the last test we need to do, Visual Studio doesn't freeze on me again, is checking and making sure the client constantly loops. while it's waiting for the client. While it's waiting for the server, I mean. Okay, we'll use the client on this side. Connection cannot be made, retrying in 2 seconds. And there we go. Now let's test out disconnection on the client side. Disconnect. And the client was disconnected. And there we go. Ooh. And there you have it. We went through quite a bit in this series. We created our TcpSocket listener for accepting TCP connections with a couple of lines of code. We created our TcpSocket for basically the same purpose, for handling receiving data past the buffer size without having to do anything funky in a lot of projects. And now you can take the socklib and pretty much do whatever you need to do with it. We didn't cover UDP in this series though. If it's requested, I'll cover UDP, but in most applications you're probably just going to end up using TCP anyway. But if you want to see UDP in the series, let me know. But there are a few other things I need to cover too, so I don't want to stay inside of Going Async Redux for too long. But you've seen, we built a TcpSocket listener, we built a TcpSocket, and we've also did a little bit of debugging at in the final video. And you can see how one or two little things can completely screw up an application. And you actually saw how we deduced what the actual issue was. Instead of me pausing the video, analyzing the source, fixing a couple of lines, and then saying, I'm a perfect coder, everything worked just fine. But now you actually see how you can actually fix certain things. Instead of being like, it's not working. Now you can see how to fix something that's not working and how you can deduce and find what the issue is. Though I hope you guys enjoyed this series, and now it's time to go off and start another one. Leave some comments below if you have any questions, suggestions, or whatever you want to talk about. Something down there somewhere. But that wraps up this series, and I'll see you guys later. Jiggly out.